Deep ocean, a mystery that's still captivating to researchers and all humans alike. There is a common idea that we have mapped more of the surfaces of the Moon and Mars than of our own planet's deep ocean. And a recent study in Science Advances confirms that we have visually explored only 0.001% of the deep sea. That means 99.999% of our ocean below is unknown to humans. So what's deep below our planet's waters, and why do we know so little? Let's find out. You're listening to a Discover Magazine exclusive podcast episode that focuses on the deep ocean. Why don't we know more about the deep waters beneath us? What's left to discover, and who is making this exploration a priority? I'm your host, Erin Berge, and I'll be asking these questions to some of the world's experts on the deep sea. Okay, so we've mapped the Moon and Mars, but we've only visually explored 0.001% of the deep ocean. That's an extremely tiny amount. But we have explored the ocean to an extent, so what have we seen? Just this year alone, in 2025, we've made some remarkable discoveries. The colossal squid, think maritime legends and folklore fame, was spotted for the first time this year. Researchers now have footage of a juvenile colossal squid alive in its habitat for the first time ever. It's actually the 100th anniversary this year of officially classifying the squid, which, by the way, can get up to 23 feet in length and weigh around 1,000 pounds. And now we have living proof. Along with this discovery, we also found a thriving ecosystem under an iceberg the size of Chicago that included various sea life like corals, octopuses, giant sea spiders, and sponges. Some creatures even dwelt at depths of over 4,000 feet. We are solving more and more of these mysteries about the deep sea below, but what I want to know is, why is there so much more left to explore? So let's start with what we know. About 27.3% of the ocean has been mapped with multi-beam sonar, and that gives us an idea of the shape of the ocean floor. This is according to Dr. Katy Croff Bell, who is not only a National Geographic explorer and the founder and president of the Ocean Discovery League. Her background is also in ocean engineering, maritime archaeology, and geological oceanography. I have Katy with me here today. Katy, would you please introduce yourself and explain to us why mapping the ocean floor is important, but why it doesn't really give us an idea of what exists there?
Absolutely. Thanks so much for having me, Erin. I'm Katy Croff Bell, and I'm the president and founder of the Ocean Discovery League. And one of the projects that my team has been working on for the past few years is to estimate how much of the deep sea floor, and by deep, I mean deeper than 200 meters, has been seen with human eyes, with video cameras, with still cameras. And it's a lot smaller than the 27.3% that's been mapped with multi-beam. In fact, the main finding of our paper that we recently published was that we've visually seen only about 0.001% of the deep sea. And if you put all of those dives together, it's only about the area of the state of Rhode Island, the tiniest state in the United States.
Oh, wow.
Yep.
Yes, tiny.
Exactly. But not only that, we also found that the locations that have been visually explored are very biased. So most of the dives that we've collected in our database of over 43,000 dives have been within 200 miles of the United States, Japan, and New Zealand. So not only have we seen very little, but what we've seen is really concentrated in just a handful of places.
That is super fascinating. And thank you for giving that brief little definition of, the depth that we're looking at in the ocean. So for our listeners who may not know the difference between, how would you define the deep ocean compared to just the ocean that we are familiar with?
Well, deep ocean goes from about 200 meters below the sea surface, so about more than 600 feet, all the way down to about almost 11,000 meters. And it covers about 2/3 of the planet. So most of the ocean is deep ocean.
Wow. Overall, I know that you mentioned that you guys are mapping, what we have visually explored. So just in general, what do you think are some of the main discoveries that we do know about the deep ocean?
Yeah, well, it's kind of incredible to think about how much we do know in that 0.001%. So there are a lot of things that the deep sea does for us humans. It supports plankton. in the upper ocean, which then produce oxygen that we breathe. Those plankton feed fish that billions of people eat all over the world. The deep sea also absorbs heat and it sequesters carbon. So it's taking up a lot of the greenhouse gases and excess heat that humans have been emitting into the atmosphere. And we're increasingly seeing pharmaceuticals and potentially, medicines from chemical compounds from marine animals. So it's amazing to see, what we do know about the deep sea just from the little bit that we've seen. And it's incredible and really exciting, I think, to imagine what more there's left to learn in the other 99.999%.
Absolutely, yeah. And going back to that number of the 0.001%, so why have we only visually seen this tiny amount, and what led you to this conclusion?
Well, a couple of things. One is that it's really, really hard to see in the ocean. Water absorbs light. And so, we can use satellites to see tree cover, habitats on Earth. We can use, satellites and telescopes to see the surface of the moon, other planets. And it's really easy to send those signals through air or space. But it's not as easy in water. So you physically have to get down there either with a submersible or a robotic vehicle with cameras or with portholes that you can see through. And you can only see a very, very small amount of the seafloor at any given time. You need to bring lights with you. And so even though we've done, more than 43,000, certainly there are more dives than that. If you put it all together, and this was the math that we ran, we looked at the number of dives, how much time people spend on the seafloor, how much you might see, how fast the vehicles are moving. And when you do all that, that's how we got this teeny tiny area. So it's sort of the inefficiency of working in water, or the challenges related to working in water. But then the biases come in the fact that being able to do this kind of work is very expensive. And so really only the high income countries that have the resources to be able to devote to work like this, to do work like this. And that's where we see the dives primarily concentrated in, for example, the US, Japan, and New Zealand, and very little elsewhere around the world.
Right, that makes sense. And so when you mentioned submersibles, how dangerous is it for humans to actually be down there in those machines?
Oh, generally it's quite safe. I know that obviously the Titan tragedy happened a few years ago, but that was anomalous. The submersible Alvin that is operated by the Woods Hole Oceanographic Institution has been deep diving since, I believe, 1958, safely for almost 70 years. And there are other submersibles all over the world that take safety very seriously, and it's very uncommon. But a lot of the work that's done is with remotely operated vehicles, which means that people aren't inside them. And so sometimes they're tethered to a ship. So you have a cable that goes up to a ship, and then the vehicles go down. Or you might have autonomous vehicles that aren't connected to the ship at all, and you program them and you deploy them, and they go and run a survey and then come back and you download the data. So there are a lot of different ways that you can explore the ocean.
That's so interesting. And then one of the questions that we are debating is, have we visually or explored more space than deep sea? I think that's a common debate I even, sometimes have with my friends and everything. But I think is such an interesting thing to think that, like on our planet that we have only visually explored the 0.001%. So what advances are still really needed to explore more of the deep ocean?
Yeah, that's one area that my team is working in, and a lot of other people around the world, actually. And in recent years, we've seen a lot of research in lower cost, more accessible systems, because, the submersibles, the big remotely operated vehicles, in addition to the millions of dollars that it costs just to build them in the first place, you also have to have tens of millions of dollars or more to operate them, to have a ship with all the equipment and crew to be able to do that. And so, with miniaturization of electronics and scalable manufacturing and all kinds of other developments in recent years, we're seeing some really exciting movement forward in low-cost, more accessible tools, which will enable countries and communities that have historically not had access to the deep sea to be able to do this kind of work, the research and exploration that's really needed.
So what's ahead for deep sea exploration? What are you hoping to discover in the coming years, and what implications does this have for our planet?
Well, I'm really excited about a few things. One is this, low cost, more accessible tools for exploration, which will enable us to expand the community, bring more people into it. It's been very much driven by the US, Europe, these higher income areas. And I think that we really need more voices in the room and more perspectives. And on the sort of where are we going to go and what we're excited about doing. One initiative that we're working on right now in collaboration with a lot of groups in the oceanography world is to set out a plan for where should we go to identify unique locations around the world that have not been visited and explored yet. So stay tuned for that. And we are really excited about the future of deep sea exploration.
We've mentioned the colossal squid discovery of this year, which Professor Alan Jamieson recently featured on his Deep Sea podcast that he hosts with Dr. Tom Lindley for actually a birthday special for the creature. And Professor Jameson, could you maybe introduce yourself and, explain why you think these deep sea creatures are fascinating and why it may be difficult for us to also identify species in the deep ocean?
Yeah, so I'm Professor Alan Jamieson. I'm the director of the Mindry UWA Deep Sea Centre at the University of West Australia. And I also lead the deep sea science program of an organisation called Inkfish. And so some of these deep sea creatures, like the colossal squid and everything else, are fascinating because they live in the largest environment on Earth, but they are not easy found. So this is one of these things that we often use the term rare to talk about them, and they're absolutely not. There's many species that we study that maybe 10 years ago we thought this was a complete rarity, a real oddity, what a great find. And then once you start poking around a bit more and you work out what depth range these things live in, and then you work out how much of the planet Earth is in that depth range, you realize that these are not rare at all. They just live in habitats that we don't go to very often. And that's the thing. So every animal in the sea does something, and we call it ecological function. And so just because we don't find it very often, you can work out roughly what size our population is, and then you realize that actually really significant. It's just the problem is human beings tend to put themselves in the center of every story. And so something like the colossal squid isn't something that we have to deal with on a daily basis. So we kind of pigeonhole that as being something rare, something far away, and if we find it, it's some strange encounter. But in terms of ecological function, there's probably millions of these things out there just doing what they do and have been doing it for millions of years. So we should go find them.
Absolutely. Yeah. And, speaking to that, you have amazing credentials on the deep sea. You have published over 150 scientific publications, participated in over 80 deep sea expeditions, completed 30 deep sea submersible dives. That's incredible. And can you tell us a little bit about those experiences, in the deep sea submersibles, and, how is it that we actually explore the deep sea?
Yeah, so there's many, many ways to explore deep sea. A lot of the time, but the first half of my career, we used a lot of autonomous cameras, so we don't physically go underwater. We drop free fall cameras down to the bottom, which use bait to attract animals to it, and then we release them from the seafloor, and we download the data afterwards, and we put the SD card in the computer and see what we've got, and that was all very exciting. And that's the sort of easiest way of getting down to about, let's say, 6,000 meters or deeper. Historically, a lot of people were using trawls, and they would just trawl the seafloor, and then you get a whole bunch of specimens on the ship, and that's how we learned a lot about diversity and so on. But that's actually, believe it or not, that's harder and harder to do. In the 50s, 60s, 70s, people were trawling all the time. Now we've kind of lost that a little bit. We've gone more towards vehicles and digital stuff. But my own personal research is really focused on anything deeper than 6,000, which is the hard bit. Not hard in terms of science, but hard in terms of access. And a lot of sort of research less than 6,000 meters will use what's called an ROV. It's a remotely operated vehicle. So it looks like a big floating car that goes down on an umbilical cable, and you can drive it from the surface. And that allows you to drive around and explore and pick things up, and you have a kind of intimacy with these animals where you can approach them and things like that, but not necessarily in person. Now, that seems like the obvious thing to do when you go really deep, but it's the umbilical, it's the tether that ties the vehicle to the ship becomes technologically really problematic. And so I ended up joining a project in 2018 where a private owner wanted to build a 2-person submarine that can go to 11,000 meters, which is our domain. And believe it or not, going down in a submersible in some respects is easier than using a remote vehicle, because you don't have this tether management problem with trying to hold on to a ship which is 11 kilometers above you. Oh. And so you're free floating. So this is what we do now, is we dive down in the submersibles, and we still use autonomous cameras to do a certain amount of research. We do that a lot, but we also then go down in the sub and we drive around for about 4 hours and we document everything that's on the seafloor, and we document the habitats, and we leave moorings down that record the water masses moving around. And so when you get really deep, it's a bit of a blank canvas, because not many people have ever really researched that area. So we have to have a combination of geologists, oceanographers, ecologists, biologists, geneticists. We do one of everything, because there's very little baseline data for places that we go. So that's what makes it really exciting, but it's very, very technologically heavy.
I'm sure. So what is it like being down that deep?
There's 2 parts to this story. There's what everyone thinks it is, and then there's what it actually is. So the question I get asked the most is, is it scary? Is it dangerous? Is it, this kind of big? And it's actually the opposite. If you can handle the claustrophobia of being in a small titanium ball for 12 hours with the hatch closed, and you can sort of psychologically delete the concept of you're now 11 kilometers underneath your safe zone, which some people can, but in fairness, a lot of people can't. There's some people sit in our submarine on deck and just go, no. It's not happening. So I guess it's for people of a certain disposition who don't mind that. But once you get over that, you're in the sub, and the first one's always a little bit nerve-wracking, because it's a very odd thing to do. But then you realize how unbelievably graceful it is. We leave the surface really fast. We leave the surface at about 2 knots or 3 knots or something. And we clear the first 1,000 meters in 15 minutes. And you slow down all the way because the seawater density increases and so on. And if we're going all the way, it takes about 4 hours to get down. And then you get this beautiful moment where it's really quiet, it's dark, it's really peaceful. And then about maybe 10 to 20 meters above the seafloor, you can just start making out the bottom. And that's a really exciting bit, because you have no idea what's waiting for you, because we're often the first people to go to a big underwater feature that might be the same size as the Himalaya. And you're just coming down on it and you're thinking, okay, we've got rocks, we've got this, and then you get closer and closer and you go, okay, we have sea cucumbers, sea lilies, all that kind of stuff. And then you drive around for 4 hours, and that's the super exciting bit, is my job as a co-pilot is to tell the pilot where to put the submarine. So I'm always looking for what we call targets. So you say this big white thing on the left, and the sub veers over to the left, and we try and document it, and then we say, okay, a big purple thing on rock, and then we go over there. And it can be quite intense. So some dives we do which are really busy. There's just loads of animals. And recently we did a big job in Antarctica where it was just something everywhere. And even at 5,500 meters, there was just animals everywhere. And, at the end of it, it's quite exhausting. But then at the end of the dive, you call it and say, right, job done. And then at full ocean depth, it takes us 4 hours to come back up again. The only bit which is a bit rough is the last 20 minutes when you hit the surface and you're now light, you've dropped all the weights, and you're waiting for the ship to come and get you. That's where you get a bit of a beating. But
oh, really?
It's totally worth it, though. Totally worth it. Yeah.
It's very incredible that you've done that. And so you mentioned all these species that are down there as you're exploring. How do species survive at these incredible depths in the ocean?
First of all, there are a multitude of species even at the deepest place in the world. So there's no place we've ever found that's void of life. The way they survive is kind of the same way as everything else survives. It's just their zero is, 6,000 meters or 10,000 meters. And what they would consider to be an extreme environment is being taken to the surface. And so some of the adaptations to deep sea are things like being able to survive on very, very low food supply. That's a big one. Not necessarily, everyone sort of focuses on the pressure. We'll get to pressure in a minute. But one of the big ones is, how do you survive in such a huge environment with so little food? And that's all, the way that animals do that is they kind of drop their metabolic rate. They have stretchy guts, so when they do come along something they can gorge themselves, and then they can turn that food to fat very quickly, so they can basically live off lipid reserves long periods of time. A lot of them have adapted mouths, so when they do find something every bite is bigger than a shallow water counterpart. So you're gorging, basically, gorging on opportunistic feeding. Then there's very low temperatures. So most of the deep sea is less than 4 degrees. Most of the deepest points is less than 2. So there are lots of adaptations there to do with dealing with that. There's some animals we bring up that are quite gelatinous, and when you bring them onto the ship, they may have passed through water which is in the 20s Celsius. And then they're on the ship, which might be 20 Celsius plus, and they do tend to fall apart. They just haven't evolved for warm temperatures. The pressure one's one of the big ones, because everyone's always sort of like, how do they withstand the pressure? But if the pressure of the animal on the inside is the same as the outside, it's fine.
Sure.
That's the thing, right? So, but on a cellular level, it does matter, because there's a couple of things that you can't compensate for, and that's each cell in your body is a sphere. And so the pressure on the outside wants to crush the sphere. So the pressure is trying to destroy your cells. So what they've done is there's lots of chemicals called osmolytes that, for example, fish and prawns and stuff use. And what the animals do is they pump more and more of this stuff into the cell as they've evolved deeper, which counteracts the effect of pressure. So then as long as the pressure differential on the outside of the cell is the same as the inside of the cell, then there's no squeeze.
Right.
So it's kind of as simple as that. We often talk about extreme environments, but again, the extreme environment is extreme to humans. There's loads of oxygen as well. Another popular misconception is there's lack of oxygen. That's not necessarily true. So yeah, it's incredibly diverse. There's things everywhere doing stuff. It's great.
Is there a specific creature that was really fascinating to you as you were down there in the ocean floor?
Yeah, I mean, before I got in the sub, one of the big things we did when we went deeper than 6,000 meters was in 2007, I believe. All we wanted to do was see if we could film a fish deeper than 7,000 or deeper than 6,000. And we figured it's worth a try. And if we did get it, it'd probably just be a glimpse of a thing or something like that. And on the second day, we got beautiful footage of snailfish, which are little tadpole-like fish that have completely and utterly taken over the deepest points in the world. They just seem to be completely just happy with that. There's one we now know in pretty much every trench. But it was really cool seeing that. And then a couple of years later, we found like 25 of them in one shot off Japan. And we're like, these things are everywhere, right? And then when I did my first ever sub dive, it was south of Indonesia in a place called Java Trench. And there's no records of snailfish there at all. There was no record of deep snailfish in the entire Indian Ocean at this point. And within about half an hour of the dive, we were just driving along and one swam under the sub. So like,
there you go.
I said to the pilot, well, that's a new species right there. And one of the questions about subdiving that is quite common is, why go down there yourself if you could just film it remotely from the surface? And I think it was moments like that where you have an appreciation of nature where you wouldn't get it from video. What you get with your own eyes is you're looking at the snailfish going, well, where are you going on a Tuesday afternoon? Because we're going up this hill, and so are you. There's little caveats like that, which you can't really articulate very well, but it was really cool. So snailfish for me were one of the biggest ones, for sure. That's great.
And I think that a bigger question that I want to ask you is just, what is the importance of deep sea exploration? What does this mean to our planet as we continue to explore what's down there?
Well, the big one is the way in which we project a map. We use a projection called Mercator. So the classic map of the world is projected in such a way to make sure that all the land is represented. Now, it's very skewed because you cannot turn a sphere into a rectangle, right? That's just the rules of geometry. So the way in which those maps are produced is you tend to squeeze a lot of the ocean because we're using the maps because we're focusing on the land. If you do a different projection, there's one called Spillhouse, where you do it so that the oceans are represented to scale and the land isn't, you suddenly realize that, this is huge. Most of planet Earth is this. And then in fact, about 70% of planet Earth is ocean. So, 30% being land. So that's how much these things are skewed in your consciousness. Now, if the deep sea starts at 200 meters, that means that the vast majority of planet Earth is deep sea. And if you take an average from the top of Mount Everest to the bottom of the Mariana, planet Earth is on average 4,000 meters underwater, which is incredible, right? So that's not even close to being shallow. That's mega deep. So the idea that we can just ignore most of planet Earth and it'll be fine doesn't feel right. And then the second part of that is, in terms of having a long-term stewardship of the biodiversity of the planet, you kind of need to know where it is and what it is. She's right.
Yeah.
And historically, I would say there's always been a kind of out of sight, out of mind type of mentality. You know, at one point where they were in the 70s and 80s, they were discussing using the deepest places in the world as a dumping ground for nuclear waste. Wow. They just figured there's nothing there, it's really deep, we'll never go there, so might as well throw it down there. And there were cases off Puerto Rico where there's huge amounts of pharmaceutical waste has been dumped. The volume is equivalent of 880 jumbo jets. That's how much material sat at the bottom of Puerto Rico. Wow. There have been cases where the plutonium generator from the Apollo 13 mission was just thrown into the South Pacific somewhere in deep sea, and there was there's loads of examples of the days where we decided if you throw it. And that was all based on the idea that the deep sea is pristine. But these days, we've got a much greater appreciation that it's not. For example, 70% of planet Earth is reliant on food from the surface. So when you see plankton blooms and jellyfish blooms and whales and dolphins and squid and fish and all these things, they all die. And when they die, they sink to the bottom. And when they sink to the bottom, deep sea animals will recycle those. They don't become a big toxic cesspit. The deep sea is not a bin. So there are animals which are munching through the sediment, keeping it oxygenated, like it's almost like ploughing fields. There are things that will scavenge on them. They will grow and then they will die and become food for something else. So it's part of the food web. It's a food web that spans 70% of planet Earth. And it's trying to understand where things are happening, who's doing it, exactly what they're doing. And then there becomes the dark side of that. So we started looking into chemical contamination about 10 years ago and found that it's actually really high. Even in the bottom of the Mariana Trench, it's incredibly high. And then on the back of that, people kept asking, well, what about all this microplastic stuff? Where's all the microplastics going? Why are the big gyres in the middle of the Pacific not more full of plastic? When you look at the numbers of plastic we're throwing in the ocean, why is it? Where is it going? And it's right. Sinking. And once it sinks to the deep sea, there's nowhere else for it to go. So it's only ever going to get higher and higher and higher. It might look like it's all dispersed. A river may have cleaned itself up because we stopped doing stuff to it. But once it goes out to the ocean, it has to sink. And so I would say probably every single subdive I've done, we've seen something that shouldn't be there. There's some places where it's just horrendous. It's just absolutely horrendous. I remember diving in 10,000 meters in the Philippine Trench and we saw like 19 plastic bags in one dive, and we found all sorts of stuff. And there was a case recently where we were doing a dive, probably 7,000 meters or something, in a place called Nova Canton Trough, which is 4 days north of Samoa, right on the equator, thousands of miles away from anywhere, a place no one's ever heard of. And we're driving along and I'm talking to the pilot saying, okay, there's a thing over here, there's a thing over there. And I saw this red thing. I thought, oh, that's caught my eye. Let's go and have a look at that. And it was just a packet of Chinese cigarettes that looked like someone had just dropped them there that afternoon.
Oh my gosh.
Like kilometers and kilometers underwater, thousands of miles away from anywhere, and you're still. And it was so pristine we could zoom in and read it. And so there is that kind of relationship where we are making changes to it, but then we're affecting something which spans 70% of the planet, but we don't know what effect we're having on it, and that feels like it's something that requires investigation, I think.
Absolutely. Yeah. And in that as an investigation, where do you see deep sea exploration moving forward in the future now?
Yeah, so I think that there's probably two major parts in or technological advances which are making it easier. One is technology, just getting eyes on the ground. That's a big one. So there are more subs now, and there are probably more ROVs in the water than have been before. But trying to scale these technologies down so they don't cost like $50 million each, because that makes it very exclusive. If you're lucky enough to get involved in one, that's great. But they're not exactly available for anyone who wants to go and do it, because the number of dives they can do a year is, even for $50 million, is still kind of limited. And there's still maybe only one. So there are lots of organizations trying to develop what are called AUVs, autonomous underwater vehicles, which will look a bit more like torpedoes, but they are much cheaper, much more affordable. You could probably, if you can get the price down, you can deploy 5 of them and get them to scoot off and document on these things. So there's a certain amount of financial challenges to be overcome via technological challenges to get more eyes in the sea. That's definitely a big one. And the other thing is the molecular side of things. That's really always, it's been taken off for the last 20 years, but it seems like it's exponential. The questions we can ask now, if you can get the sample in your hand That's the big thing, right? So you get technology will give you the sample in hand. What you can do with that sample now is great. Back in the day, it would go in a jar of formalin and end up in a natural history museum, and it'd be given a name, and that's where it would stop. But now we can do all sorts of things. We can look at the phylogenetic relationships between that and other animals. We can look at pressure adaptation. We're looking at gene expression. You can look at heat shock proteins. You can really understand what it's doing. How you can sequence its entire gut to microbiome and find all these wonderful, interesting strains of bacteria who do all sorts of interesting things, which we couldn't do before. So, and now we're at the point where just even yesterday, we're having a conversation about how many full genomes we now have. And, think about that, having that conversation even 3 years ago would be ridiculous. So I think that and that's also a technological advancement. It's the laboratory versus getting things in the water. So I think it is definitely taking off, and there's been papers published recently that show that the number of organizations, the number of countries, the amount of effort is actually really on the up, because people are understanding that the ocean isn't split between the easy bit on the surface, the shallow water, the coastal bit, and then there's the deep water bit, which is the scary bit that nobody goes to.
Yeah.
This imaginary line that we've drawn that says shallow is easy, that's the important bit, in the deep seas. That I think those lines are getting blurred, which is great, and you start to think about it more as one big body of water. And I think when you find a packet of cigarettes at 7,000 meters, that's a really good example of how there is no shallow versus deep sea. It's all the same thing. For people who are interested in deep sea, is that two parts to this. One is I know a lot of young people are a little bit skeptical in terms of getting into deep sea because they feel it's not easy and there's not many jobs in it, and it's an exclusive club of big American institutes that go on Discovery Channel, and that's not the case. There's actually deep sea scientists in most universities now. There are huge amounts of opportunities, and there's great big networking opportunities, and there's lots of early career opportunities now that weren't there 10 years ago. And so that's a bit of a hangover from decades before, but there's certainly a lot of jobs. And the other thing is to question the narrative. And that's the big one for me. This is one of the reasons why we do our own podcast and stuff like that, is the media often sell us a visual imagery and a impression of the deep sea that really isn't fair. These are not animals that are lurking in the deep waiting to kill you. They're just doing their stuff. They just look unfamiliar to what you are used to. And when you start to question everything, which is the job of a scientist, right? There's certain people who can't help it. They just question everything. So they're destined for a science career. If you look like something like the most ugliest, horriblest Black Sea devil anglerfish, and you reverse engineer it and say, why does it look like that? And you think, well, where does it live? What does it eat? How does it reproduce? And then when you break it down, you go, well, that's the only shape and appearance it could be. It makes perfect sense. And so suddenly it's not so scary anymore. And then that's the only way I think that humans will develop a real proper relationship and stewardship of the oceans, if you actually truly understand it and stop with it's a scary, horrible, dark abyss where sea creatures lurk and want to come and do you harm. So if we can rethink of that, an animal doesn't have to be pretty to be important.
A huge thank you to Katy and Alan for taking the time to speak with us today. I'm Erin Berge, the Senior Digital Editor at Discover Magazine, and that's our take on the deep sea. Hopefully you all are inspired to learn more and to stay curious.